Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 5 for Basics of Unsupervised Machine Learning. Now let's see the TSNE. This is how it looks like. Why so many dots? Because this is diabetes dataset that I have downloaded from the internet and it contains 769 records. So there are many records here. So pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, age, outcome. So all these things are available here, and to make sense of this data, so you can see there is lot of data available here, and reading this data and understanding this data will be very complex. So what you can do is use this TSNE technique and it will look like this. So this is component 1, this is component 2. So these are not the same component from the CSV file. This you cannot say it is glucose, it is skin thickness. No, this is not the thing. The algorithm that is working in the background is doing this, distributing the things in two components. This is what automatically being done by the algorithm. We don't have to do it manually. So let's see. That technique is a technique that takes data with lots of feature, again the lots of feature, and reduces it down to 2 or 3 dimensions so that you can plot and visualize it. So it is unlike PCA, which focus on capturing variance in the data. So what do you mean by variance in the data? Huge differences in the data. So for example, we have 1000 or 1 lakh. So huge differences means the variance in the data. So TSNE is specifically designed for creating meaningful visualization by preserving the local structure of the data. So it tries to keep similar data points close together. This is what it will try, TSNE. So now the question comes. I already told you to reduce the high dimensional data we use PCA. Then I am telling you that you have to use TSNE again. So you will ask me question when to use what. So I have already included that in this article. So this is better for visualization. TSNE is particularly good for visualizing clusters and grouping in complex data sets. It often provides more clear and visually appealing result than PCA. When data is non-linear separable, then for visualizing cluster, for visualizing, this technique will be better, TSNE. And if you just focus on local structure, while PCA tries to capture the global structure in the data, TSNE focuses more on local relationship. So what this TSNE will do is focus more on local structure, which means that data points are points that are similar stay close together in the visualization. Data points that are similar stays close. See the closeness, better for visualization. Comes the question, how does TSNE work? Without getting too technical, let's see. TSNE converts the relationship between points in high dimensional space, which means your original data set. As I have shown you, it contains lots of columns. So this is in technical terms called a high dimensional space, into probabilities. It then arranges the data in lower dimension like 2D or 3D. As you can see, this is in 2D, while trying to maintain the structure from the high dimensional data. It places similar points close together, dissimilar point far away, giving you clear visual separation of groups or clusters. So in this chart you can see the separation, and visually this is more useful. Let's see the example use of TSNE. You just have to remember the concepts. Don't go too deep into the things, because you have to focus on creating the projects. These are completely mathematical. If you go deep into these techniques, then the thing is you only want to go too much deep in the things if it is very important for the particular project, and if you are working on that project for more than 3 months, one similar project, then you have to go deep into this. But for the general purpose, just remember these techniques are available. You just have to remember that these techniques are available, and you can just find the code anywhere on the internet and use it. Just remember the concept. Key difference between PCA and TSNE. PCA focus on capturing the maximum variance in the data using linear combination of feature and is often used for feature reduction and interpretation. Feature reduction and interpretation. These words, remember these words: visualizing data, TSNE. So, but it doesn't try to explain variance and more compute expensive than PCA. So what this means is, if you run these kind of charts with lot of data, then it requires more computational power on your computer or server. So TSNE requires more power to visualize the data. When to use? When your main goal is visualization, especially in situations where PCA doesn't provide clear result. So you can try running PCA and you are not getting the result, go for TSNE for visualization. When your data has complex non-linear relationships that are hard to see in simpler dimensionality reduction methods like PCA. So PCA is basic. If it is not working and you have some complex data, go for TSNE. So for simplifying data, PCA; for visualizing complex data, TSNE. I have shown you the example, also included this output. I will continue this session in next video. See you in next video. Have a nice day.